Tell me what you guys know about plate tectonics.
They're underground and
Okay.
move, creating earthquakes.
Right? Earthquakes are an example of something that they could do. Volcanoes are another example.
Yeah, and near plate boundaries, eruptions can occur.
Right. So yeah, that's also enough. Like with volcanoes, those are related. What about convergent and divergent plate boundaries? What's the difference?
Convergent means two plates
Converging, right? They're pushing together.
yeah,
And what about divergent, Connie?
sliding on top of each other.
Diverging would be like they're diverging, so they're coming apart, right? And then there's another boundary, transform ones, right? So what do?
They, like, one slides past together.
Right. So they're not pushing together. They're just sliding past one another. So plates interact with each other. Some push and some spread apart. And because density, some rise and some sink. At converging plate boundaries, two plates come together. Okay. So let's look at this first. See, like right here, these are coming together. So let's see, the Pacific plate right here, this one here, that's an oceanic plate. What's the difference between oceanic and continental? Do you know, like, one is more dense than the other? Okay, so which one's more dense?
Continental.
Continental is actually, it sits on top of the oceanic, right? So it's a little bit less dense.
Oh.
Okay? So when those two come together, when something is more dense, does it go on top of or does it go below?
Below.
Right. So when they're pushing together, the oceanic plate goes like this and pushes under. So it starts to, do you guys know a vocab word that's related with that? Subduct, maybe?
Yeah.
Okay. So they start pushing and this one subducts. So when the subduction occurs, down here, this starts to melt. So that creates what? If it's under the Earth's
Magma.
surface. Right. So if it's melting and creating magma, with density, if it's melting, it becomes less dense. So what happens? It rises or sinks?
Rises.
Right. So it starts rising up through the Earth, and then all of a sudden it reaches the surface, and it erupts. And that's how volcanoes are formed. So that's our convergent plate boundaries. At divergent plate boundaries, it's kind of a little bit different. They're a little calmer, and most of the times they're underwater, so we don't really see them happening. What happens is when they're pulling apart, the Earth's crust that's left there becomes thinner. So all of a sudden the magma rises up because it's thin and less dense, and then it starts to like ooze out and push the plates apart, diverging even further. So that kind of helps. So like, do you guys know, in the middle of the Atlantic Ocean, do you know a big ridge?
Yeah, the North Atlantic Ridge.
Mid-Atlantic. Yeah, there you go. All right, so that's an example of a divergent plate boundary and how magma comes out there. Those are also called rifts, right?
Yeah.
All right, so let's see where we are. So we already covered what plate tectonics are. It's the key principle that the lithosphere exists and is separating into separate plates which float on the asthenosphere. Converging plate boundaries, we already covered. Diverging plate boundaries, we got. Okay, so volcanoes, we just got up to. So that's an opening in the Earth's crust that naturally occurs on the surface in which molten gas or solid material is ejected. All right. So volcanoes form by the magma in the asthenosphere rising up, and then it hardens eventually and makes those volcanoes. Let's get on with this. Okay. And then an example of a hotspot, which is a different type of volcano. Do you know what a hotspot is?
Yeah, I think I do.
Okay. What do you think it is?
It's a hot area where like lava and magma is underneath.
Right, it's just like a hole in the crust, right? Okay, so it's a weak spot in the crust. What were you going to add?
I was gonna say it's an opening in the earth, but that's a volcano basically.
Okay, so yeah, so that's how it forms. It's just an opening in the Earth's crust which magma gets through. And since the Earth is constantly moving and with plate tectonics, what happens? Like, how do those islands form? Like, if they're going over the hotspot, how does it?
The volcano erupts.
Yeah, at one time, and then...
And it's land.
Okay. And then as time goes on, it keeps getting bigger as it passes over it, right?
Yeah.
Okay, so that's why Hawaii looks like that cool chain, because it's been over time. It's like there's like a 14 million year time gap between the oldest and the newest.
Yeah, and there's gonna be like a new one in like 100, like a million something years.
Really? Yeah. It's gonna. I mean, they're continuously forming. Okay. So the lithosphere is the crust, right? And the asthenosphere is the molten part that's underneath. So that's the part that melts and comes up. So we saw these plate boundaries. Okay. So this is like an example of a convergent one. So here's the oceanic, and this is it subducting, like I showed you, and this is the continental. Okay. Do you guys know about the Ring of Fire?
Yeah, like this big.
Right. It's this plate right here. And what is cool about the Ring of Fire, or why is it called the Ring of Fire?
Because it's where a bunch of different plates join up with one other plate.
Right. Well,
I was
okay.
also told that kind of looks like the devil.
Ah, it's kind of weird. Yeah, I guess the horns.
And like the chip.
Yeah. All right. Well, the Ring of Fire is called the Ring of Fire because it has a lot of seismic activity, and it also has a lot of volcanoes located there. What is seismic activity?
Like earthquakes.
Perfect. That's exactly what it is. So, the Ring of Fire just so happens to be a place. Let's go back. So this is North America. Here's South America. Here's Australia, and here's Europe and Asia. So let's just look at this plate here and all the boundaries and what they are like. Okay, so what kind of boundary is this if it's coming together?
It's a convergent.
Right. And if these ones are coming together, that's also?
Convergent.
Right, so these all here are pushing together, so it's scrunching up over here. Now these ones here are going apart. What are they?
Divergent.
Right, so they're pushing apart. So the plate's going this way. So it's going to cause a lot of seismic activity and volcanoes. So now we're going to go back here. Okay, and that's the end of this. Okay, so we are going to now construct our own volcano.
Cool.
Alright, so then we're going to do this. We're going to do this, and it's going to also show us chemical reactions and how carbon dioxide is formed when we mix baking soda and vinegar. Okay, so volcanoes are all over the world. They have occurred all throughout geologic time, and it's how our Earth formed. So without volcanoes, we wouldn't have oxygen in the air, and we wouldn't have water either, and we wouldn't have the land that we stand on. So I guess we could do that.
Thank you.